This section describes a floating ground in the context of high-voltage systems and its safety implications. BEVs utilize two-wire high-voltage systems, where the battery circuit avoids direct contact with the vehicle chassis. In a two-wire high-voltage system, the electrical circuit is completed using two conductors, one for the positive voltage, typically referred to as the hot or positive plus wire, and one for the return path, often referred to as the neutral or negative minus wire. These wires carry the electrical current between the various components of the high-voltage system, such as the battery pack, electric motor, power electronics, and auxiliary systems. Floating ground describes the condition where the negative terminal of the high-voltage system is not directly connected to the vehicle's chassis. Instead, it floats or remains isolated from ground potential. This ensures that there is no direct electrical path between the high-voltage system and the chassis, reducing the risk of electrical shock or damage to the vehicle's electrical system. It is called a floating ground because the circuit lacks a reference point to Earth-like standard 12-volt systems. This isolation system improves safety by preventing accidental grounding and potential electric shocks through the chassis. High-voltage components like the battery, inverter, and motor have dedicated positive and negative high-voltage wires for power delivery and return paths. These wires are also isolated from the chassis. Technicians familiar with 12-volt systems are accustomed to identifying ground wires connected to the chassis. This grounding path allows for fault detection and protects against shocks. In high-voltage circuits, the absence of a chassis ground means technicians need to be aware of the unique wiring configuration and follow specific safety protocols. Each high-voltage component has its own designated ground wire within the isolated circuit. Some BEVs utilize 12-volt auxiliary systems for powering low-voltage components like lights and infotainment systems. These systems typically follow traditional grounded wiring schemes with connections to the chassis ground. Technicians working on BEVs require specialized training and safety equipment to handle high-voltage components and diagnose potential faults within the floating ground system.